Hi, and welcome to Industry 4.0 Transformation with AWS for Industrial. My name is Michelle Putnick. I head up our worldwide business development function for industrial manufacturing. It's a pleasure speaking with you today, and I'm honored to have an excellent customer of AWS's on this stage with me. That's Dave and Martin from Coke. They will join me later in this session. But stay tuned, and we all look forward to hearing their story around Monitron and look out for equipment and their implementation of those solutions. So with that, I just want to get started. So today we're going to wrap up a little bit about AWS for Industrial. We announced it last year at reInvent. What have we been doing in the meantime? How have we progressed? What have customers done? Partners have built on top of these capabilities that we put forward during that time. Then I'll hand over, like I said, to Dave and Martin, and they will walk us through a really fascinating story around their implementation of Monitron, number one, and number two, their implementation of Lookout for equipment. So it'll be a jam-packed session, and I hope you look forward to it as I do. So customers have come to us over the last few years, I would say, and really asked questions about a set of, let's say, workloads or areas, right, such as supply chain. You guys know a thing or two, it seems, about supply chain. How can you help me in this particular area? And in this day and age, where we have significant challenges getting goods to one place, from one place to another, it is certainly a pertinent issue. The smart products and machines, that's another category where we've seen a lot of interest over the last few years. How do I instrument my product, whether it's a consumer product or more of a business-to-business product, with intelligence and smarts, so that I can innovate on top of that, so I can create new and differentiating relationships, so I can innovate maybe different business models associated with those smarts and those capabilities. We see that across automotive, high tech, industrials. We see it in a lot of different areas, frankly. Production and asset optimization, so all the smart factory capabilities and questions around that. Still a lot of interest here. How do I become more efficient around my factory operations and my portfolio around my plants? And as we just come off of a significant discussion around sustainability in the world, and how do we make caps to emissions? This is really an area where there's an opportunity to, with that efficiency or drive, we can really start tapping away at sustainability metrics. So that's a great opportunity to pursue, and customers are saying that as well. In the engineering and design space, still a lot of interest of moving some of those capabilities and workloads from maybe an on-premises situation and bringing that into cloud. Quality management for sure, that also taps into the better quality we have, potentially the less defects and scrap. Again, it hits our sustainability posture. Worker safety and productivity, still top of mind, of course, that's job one. But it's also been, as we've watched last year, it's a little bit of how do I separate work cells, how do I separate people, and so on and so forth. So collectively, these six areas are still squarely in the line of sight of what companies are looking to do and looking to achieve. And there's no, right way to start, or, hey, should I be moving, left to right, or right to left, or in the middle or something? It's really up to each company and to determine what's best for them. Where is there, more bang for the buck? Where do I put my investments? Where do I see challenges? And how do I uncover, some of those by working with AWS and its partner ecosystem? The good news for us is, yes, we learned a thing or two as an organization. We've certainly, put our ear to the ground and listened to what Amazon have done in there, with regards to supply chain, but also, the manufacturing operational side of Amazon. So how do we make sure that servo motors are working? How do we make, tension rollers, labeling machines, all the types of equipment that we have, robotics, obviously. How do we make sure that that is up to snuff and works, so that we always, make that commitment to our customers to deliver on time as promised, and don't, break those promises. And that really starts with, in our case, or in Amazon's case, it starts with forecasting. It goes through to workforce planning and the capacity needed to address that particular forecast in that particular geography, to sourcing from vendors and placing that inventory and that volume of inventory, close to where that demand is, and then essentially fulfilling that from a production plant perspective, and then looking at the first and third party logistics flow. And the beauty of all of this is, since there's a lot of volume at Amazon, this has to be, if not 100% automated, like in vendor buying, it says 99% inventory automation. It needs to be very close to that 99 or 100% in terms of driving automation and decision making, because the volume is so great. That said, it's also recognition when customers come to us, they say, well, we don't have the problem of the volume, but we do have a lack of accuracy. We do have a lack of visibility. We do have a lack of, whatever it may be. So with your, experience that you have in and around supply chain, are there areas that we could potentially work on and address together? So those are just some examples. Now, another area which we heard last year at reInvent, this year as well, is how do we find simplicity in a yet very complex world? I'll paraphrase here, customers tend to like, the Echo devices and the, Alexa that powers that. The experience from, going on Amazon.com, buying things or looking for things, or the Amazon Go store, how easy it is to just walk in, identify yourself with your palm or a QR code on your phone, and then pick up whatever groceries you need and then walk out. How do I bring that to the context of the industrial space or the manufacturing space? And that's really been a, top of mind for our development teams, to think simplicity in that complexity and apply it wherever we can. And you're starting to see some of the fruit of that labor. If you think about, Monitron, Panorama, Lookout for Vision or equipment, etc. You bring your data, and it runs through a workflow. It runs through a set of machine learning algorithms, and out comes a result that you can do something, with. And in the case of Monitron, if you haven't tried it, I highly recommend you do it, and we'll hear more about it from Coke in a second. But the onboarding experience, it's super important that this is easy to do, and doesn't require a village of people every time I'm going to put a new sensor here. Where do I put it on electrical motor versus, a tension roller or this, that, and the other type of equipment? Well, it comes with instructions and recommendations of where to put it and how many sensors to put on a specific kind of motor, for example. How do I connect the sensor package to the gateway? How does that work? So the onboarding process through from the Amazon console or AWS console to the experience on your phone or on the web interface, super simple to follow. Anyone, can do it. Doesn't require data scientists, doesn't require, a village of people to get it done. But just with limited capabilities and understanding of, a compute environment, you're off to the races. And that's really the intent here, to bring that simplicity in other experiences that we have around the, Amazon family, bring that into the industrial landscape, and get going and get to results. That's at the end of the day, all we want to do is get to those results. And you'll see, more of that hopefully during reInvent. So that you can come back to and think about, oh yeah, now I get it. You know, they're making it easier for me to consume these types of services and to get to results, you know, quicker. And if you look at that, not only from our perspective, but from what our partners are doing, you know, we kind of look at this from a, you know, we have a number of capabilities, right, on the left-hand side of this slide, you know, edge analytics, AI ML, you know, capabilities, you know, data lakes, dashboarding, digital twin, workflow engines, you know, fleet management for robots, et cetera, et cetera. All of these capabilities are there, and they are for, you know, it's just kind of a single pane of glass to get to it from a developer standpoint. But then how do I bring that over to more an application or a solution, right? So we think about those as industrial applications, and how do I translate from the capabilities that are there, ours, AWS, our partners' capabilities, and bring those over to applications that are ready to roll, ready to be executed, ready to deliver results, right? I want to do robotic automation, or I want to do track and trace, or I want to do, you know, a virtual land-on system, or a warehouse management system. Well, you know, Siemens, Accenture, Deloitte, Infosys, Slalom, Seek. Again, this is obviously not an exhaustive list. These are just a few examples of partners that are building these industrial capabilities, or built on these capabilities, these industrial applications that so you can get to a solution and get to these opportunities, regardless of where you want to start in those kind of 6 buckets that we talked about in the beginning. But really, you know, focus on the goal of achieving those rather than anything else. So it's important to look at this, you know, and I've said it before, on this, you know, virtual stage and also on the physical stage at reInvent. This digital transformation opportunity is not an individual sport, right? This is a team sport. That means no one can solve all of these things on their own. Not you, not us, not one particular partner or one particular other company, right? It really takes a host of people that brings this together from a knowledge perspective, from a technology perspective, from a business capability perspective, knowledge about your business individually. Once you bring those assets together, yeah, some magic can happen. And we can certainly build in some shortcuts, like we've talked about now in and around Monitron, and look out for Equipment and Vision, and Panorama, where we've seen this a number of times. So let's take the heavy lifting out of the equation. Let's try to package that up in a way that it's fast and it's easy to get going. So with that, I'm really looking forward to this next session, and I'm going to hand over to Dave, who's going to take us through some of the amazing experiences that Coke has had over the course of the last, or this year, I should say. So welcome, Dave, on stage.
Thanks, Michelle, for the introduction. For Coke Ag and Energy Solutions, I'm represented by Dave Croning, IT leader focused on improving operations and reliability through technology solutions. I'm going to take you through a couple examples of Monitron, and then pass it over to Martin Miller to talk through Lookout for Equipment. So introduction to Case. Case is a global provider of value-added solutions for the agricultural industry. We have 4 main pillars within our business. Fertilizer, which we produce and distribute over 13 million tons of fertilizer annually. Coke Ag and Coke Energy Services focuses on the value chain for natural gas. Methanol, which we now manufacture but also distribute methanol. And then Agronomic Solutions, which provides value-added fertilizers for turf and ornamental businesses, as well as increased overall yield and efficiency while reducing environmental impact. So that's a brief overview of Case. And now I'm going to step you through our exposure with Monitron and our deployment at our facilities. So where we started, we were looking for a technology solution that can be applied across our business on thousands of assets to really prevent failure, where we approached this was okay, what's the big idea? How do we start small and then scale fast? So in this scenario, we were focused on the assets that we potentially run to failure, or that's the strategy that we have approached. And we said, what data can we get? What insights can we get from those assets? And how can we monitor all those assets, which is a big task since there's thousands of them. So we procured and implemented the Monitron system. So started small, picked 5 assets that we could start with, get the insights from. And then we talked about how can we scale. So how can we minimize the procurement cost, the data cost, installation labor. So the broad opportunity was applying technology to thousands of assets and gain insights from them. So as we started, we had a lot of key points of view to achieve this, and these came from learnings in the past on implementing this sort of technology. But first and foremost, it has to have or require minimal to no expertise from an IT standpoint and an operational standpoint. So I should be able to hand the devices off and be installed with minimal impact. We figured out that overall vibration is a key indicator to the asset health, and so that's the key point that we want, key data point that we're pulling off these sensors. Typically, what we do is we go do operator rounds and we go look at the equipment twice a day, or we take a vibration sample once a month. And so continuous data is really going to tell us the whole story. Low cost is critical with thousands of assets. How can we go deploy something that's cost effective to monitor the assets? And then we also wanted to leverage our existing infrastructure. We've deployed wireless technology out in our facilities, and we want to take advantage of that. As well as minimize the number of systems that we have data going into. So this eliminates the distraction from the end user of understanding where is my data, how do I access it, and what system is it in. And then as well as if we do have an issue with an asset, we just want to be able to rip and replace the sensor. We don't want to have to worry about pulling the sensor off. Is it still working, functioning? We're okay with it being discarded as the asset is being repaired. So now the approach, the overall architecture of the solution, very simple. We start with the asset that we're going to monitor. We go attach the Monitron sensor via epoxy, and then we install the gateway. From that standpoint, it's connected onto our wireless access points, and the data starts flowing seamlessly right to the cloud. So where we take advantage of this data is we pipe it into 2 locations. We go into our data historian as well as the Monitron application itself. So once it's in our data historian, we run our own AI ML models to detect failure, as well as we also leverage the app provided to our SMEs. So that's the simplistic data flow of the Monitron solution. So our current deployment, I'm going to go through the deployment and then get to some insights, but we've deployed 125 sensors across 5 sites so far. So this is manufacturing sites as well as our distribution terminal network. We intend to scale to 2,000 sensors across our fleet and terminal network over the next 18 to 24 months. So as you can see in the images above, we've had a simple time connecting. On the left there, connecting the sensor to the app. The middle image is going to give you an idea of the Ethernet gateway that we attached, and then on the right is the detailed version of the epoxy and the sensor attached to the asset itself. So let me step through the insights that we have gained from this system. So starting with a blower in our facility, what we had been alerted to was the app had sent us a notification saying that you're in alert state, you have high vibrations on a blower, and so we talked to the operations team. They went out, and sure enough, the blower was plugged. So the operator shut the blower down, cleaned the filter, turned the blower back on, and we were back at a healthy state. So this is a key indication that the application, the ML models in the background do work. They provided us the insight to a potential failure, and we're able to leverage that in an operational state. So our point of view is that if we have the application running on the operator's phones, they can be notified, alerted, go out, change the filter, minimize the amount of steps in a workflow, and come back and continue operating. So this saves us thousands of dollars through not only human capital in our workflow process, as well as not letting the asset fail and keeping it running at a healthy state. The other two that I want to talk through was, I talked earlier about continuous data. You'll see on the left here, this is a motor and a pump setup where we would not have seen these spikes in the data set previously with our operator rounds or our monthly vibration sensing. There was cavitation that was occurring within this pump, and we were able to capture it within the data set, allow the operations team and maintenance team to go correct the issue, and then turn this pump back online. Typically, what would happen was we wouldn't see this. This would damage the pump, damage the motor, and then the pump and motor would fail. We'd switch over to an alternate in that scenario and cause a lot of waste within our process. The one on the right here that I want to talk through is the way we approach temperature sensing. Within the Monitron system itself, it gives you vibration as well as temperature. And we use the temperature indication on our reciprocating compressors to understand when we potentially have issues with our valves. And we installed 4 sensors on the valves. And what we did was took individual readings from those valves, and we plotted them here in our tool, which is Seek. And you're able to visualize those temperatures across those valves on one trend line. So the data that went to our historian, now we can visualize via Seek and see the deviations across that asset. That allows us to make adjustments to those valves and keep them running in tune and in line as we progress forward. So very insightful. Appreciate the simplicity of Monitron and the data that it provides from the system. So where are we going next? We see the opportunities are to continue to work and develop this product with the Monitron team. First and foremost, we want to increase the data sets. So what other information we have around these assets can we combine to get better insights into the operations, as well as continuing to let the data run and the Monitron models continue to develop and provide additional accuracy as we go forward. The second one is focused around how do we indicate what the operational states are of that asset? So as we turn the asset on and we turn it off, how do we know that and tell the application that so that it can train and not give us false positives? So if we're outside of a steady state, we can provide that insight to the Monitron team, the Monitron app, and eliminate those distractions. And then the third is increasing diagnostic capability. So in that example that I gave around the filter, the plugging, can we just let operations know, hey, we've seen this state before. Let's go tell the operator what to go do so he could plan better and not avoid a trip out to that motor or pump or blower and know what he has to go do. So the last thing is really we're at a point where scale is going to be key. So the number of data points that we can capture, monitor, and provide insights back to operations is the value. So we're looking at this system as the lowest price point to gaining insights to our assets, and then as well as enable the operations to take that data and do something with it, which eliminates the reliability issues that we have and most process plants see, as well as keeping us producing tons at the most optimal rate. So with that, I'm going to hand it over to Martin, who is going to talk about Lookout for equipment and give you an overview of what we're doing within that space. Thank you.
Thanks, Dave. Privileged here to be up on stage talking about AWS and Lookout for equipment. I'm going to walk through Case's application and how we've deployed this across our sites. So same flow, same concept. The opportunity for us was how do we actually successfully implement and scale predictive maintenance across hundreds of assets, critical assets across our sites, knowing that each asset has a lot of unique operating conditions. And when it comes to scaling our ML models and scaling our capability within a resource constraint state, not having a dedicated team of data scientists or thousands of data engineers able to source the necessary data, how do we actually achieve this at scale? And so we've partnered with the Lookout for Equipment, the AWS team, and we've been able to have great success in actually leveraging the platform, modeling the equipment behavior, and diagnosing failures, diagnosing issues before they become an actual failure. And so our think big, start small, scale fast approach was really centered around developing those asset-centric models to leverage all the data, all the critical data associated with those assets. Our focus was quickly deploying those models on a small subset of key assets across our sites, and with the mindset that we were resource constrained, that there are unique conditions and operating states for these assets, and that we do have thousands of sensors and a very an existing architecture today that when it comes to sourcing that data, gathering those insights, and consuming that. So key points, things that were in our forefront when it came to developing this solution is that when we wanted to have minimal to no ML expertise required for the operations or the engineering team when it came to developing these models. We wanted to have a holistic approach, meaning we wanted to be able to capture all the data around the machines and around the assets that we had today. We wanted the models to be asset-centric. We wanted them to be unique to the asset based on the operating conditions, based on historical operating states for that asset. We wanted this to integrate with the existing workflow that was already in place for the operations and the engineering team. So we didn't want to provide them new tools, new technology outside of the existing processes, the existing technology that they were using today. We wanted these models to be developed in hours, and so speed was of the essence in terms of the sites and the engineers that already have the workflow, already have the process of leveraging platforms like Seek today when it came to building out their analyses around those assets. We wanted the ability to scale this in a way that we could increase our ability to monitor, detect, and understand if there were deviations or potential failures. The other component within this is we wanted accurate and we wanted transparent ML models. We didn't want a black box. We wanted the ability for the operators and the engineers as they built these models to get the feedback, to understand what are the conditions, what are the operating states, what is the model actually telling me, and what's driving our potential failure. And again, the final point here is leveraging our existing architecture. How do we take advantage of what we've already invested when it comes into platforms like Seek, when it comes into AWS and our existing data lake, our existing cloud? How do we leverage the existing connectivity within our OSI, our PyHistorian, and get the value that's already been invested? And so how does it work? Let's look under the hood and let's provide you an overview of the partnership that we've had with both the AWS team, the L4E team, and Seek. And so a very simple diagram, a very simple flow here of how the actual information is consumed, fed up to L4E, and then provided a feedback and input back to the actual process engineer. And so users today, operators and engineers can actually build all of these models within the Seek workbench. The individuals can identify their assets, leverage the existing AF or the asset framework structure that we have today, identify those key processes and those key points that they're wanting to model around those assets. And again, the key thing to keep in mind as you look at this, the operators and the engineers and our data scientists are not interacting with L4E. They're in their existing workflow, they're in their existing technology that they're comfortable with and know today. Those process engineers and operators are able to actually build those models within minutes, deploy those models within a click of a button, push that to L4E. Then they get the interaction back in terms of after the model's been trained, after the inference has occurred. They then have the continuous monitoring and the uplift that we've seen from L4E. Seek to then displays those inputs and results back to the users, giving them the feedback, giving them the ability to analyze the ML models that we're getting from L4E. So the key thing to highlight here as we approach this is that ease of use, that ease of flow, leveraging our existing architecture and our existing partnership with Seek. So from a current deployment standpoint, we have this across 5 of our sites, 41 critical assets, and we're targeting to scale to hundreds of our existing critical assets within the next 12 months. The other thing that we've identified as we've gone through this with the L4E team is not only are we able to analyze equipment health, but we're also seeing applications around the process health and identifying deviations from a process standpoint. So now I'm going to walk through a particular use case where we actually have had success within our use of L4E. Within this example, we're looking at a major compressor, and L4E was actually able to detect this failure hours before any of our other monitoring or our existing anomaly detection processes. So L4E correctly identified and alerted to a bearing temperature issue on this major compressor. What this then provided us was the ability to detect and also then monitor this potential failure before it became a bigger issue. What we also saw within L4E as it continued to diagnose and monitor this issue was provide the operations team and engineering team the feedback on how do we continue to maintain and operate this asset without bringing down our production process, but keep it in a healthy state. And so the uplift that we saw from L4E was that it continued to inference, it continued to monitor this asset and provide the proper feedback and the diagnosis over time of changes around that current operating condition. This then allowed us to develop a short-term mitigation as well as a long-term mitigation to ensure that this asset continued to operate during high-value times for us in current markets. So what are next steps for us from a case team? First off, I'd like to thank the AWS L4E team, so Brent Swindler, Alicia Trent. I'd also like to thank the Seek team, Chris Orr and Chris Herrera. And then also from a case perspective, Michael Robinson and Hunter Lowmaster, who were critical in both the deployment and our success of capturing value within this use case. I think Michelle said it well, it takes a village to create value here within these use cases, and we've seen that partnership from the AWS team as well from the Seek team. So we look to continue that partnership with the Lookout for Equipment team, leverage the learnings and continue to optimize and scale our usage across our critical assets. We also look to continue that partnership with Seek as well as Black & Veatch from a monitoring and diagnostic standpoint. So accelerating our use of these ML models across our critical assets, looking to, again, strategically apply L4E not only on the equipment side, but also on the process condition side, where we continue to see value there. And then increase our exposure across the fleet for our reliability SMEs on how easy and how quick we can deploy these solutions across our high-value assets. So with that, I appreciate everyone's time, and I'll pass it back over to Michelle.
So guys, thank you. Martin, thank you, Dave. This was an amazing session to be able to stand here with you and having you folks teach others of how to get this done in very short order is just amazing. It's humbling. I very much appreciate it, and I'm sure a lot of our listeners appreciates this story or these stories as well. I love when companies come here wanting to share the stage and more importantly, tell them about their experiences, right? The good, bad, and the ugly, right? There's bound to be some pitfalls, right? Where some of these things we're doing for the very first time. We're solving them in a very different way from maybe what we have been able to solve for in the past. Or maybe there's been it's just too costly to solve in the past and we've kind of, run things to failure. This starts changing things. This starts changing behavior and certainly the way we think about maintaining equipment also going forward. There are financial impacts of these types of technologies in terms of the problems that we try to avoid by applying these types of technologies. So there's some really exciting things going on here. And I really encourage each and every one of you listening to this, if you want to share your story in one of our podcasts, again, just let me know. We're happy to hear your story. And back to my earlier comment, this is a team exercise, this digital opportunity, right? You think about it maybe in the context of your company, but think about it in your company and also your end-to-end supply chain. Some of which may be mom and pop shops that supply a plastic widget to you. How do you make them, part of this journey? Can you make them part of this journey? What kind of templatized approach can you take to support, a tier 4 supplier, and a tier 3 and maybe tier 2s and 1s are more able to get some of this, done themselves. But really think about how you stretch this across and along your supply chain as well. So again, thank you very much. Thank you, Dave. Thank you, Martin. And I look forward to see you soon again. Thank you.